Hello everyone, thank you for joining. My name is Phi Bang and my colleague Trung Lê. We are both from NSD. Today we will present a fun demo how to mirror and control Android phone using I.MX RT1170 with Zephyr Atos. So here is the agenda. First, we will talk about the motivation, why we started this project and what we wanted to achieve. Then we will explore some existing approaches and present our solutions. Finally, we will discuss about the system performance and share some insight about the future improvement. So for the motivation, today we see smartphones are integrated into many vehicles. For cars, we have Android Auto and CarPlay. But both of them are proprietary solutions and need powerful processors running rich operating systems like Linux or Android. So we asked two questions. For two-wheelers like the motorbike or e-bike, can we build a solution that is open source, similar and cheaper? And the second question, can we use a microcontroller running Zephyr Atos to connect the phone with the vehicle? So that's the idea behind our demo. Next, we will go through some existing methods in the state-of-the-art. The first and the easier question is how to mirror an Android phone screen on PC screens. So as you can see, the first seamless method would be this ADB command. It will run the screen recorder built-in application in Android and streaming video to VLC or ffmpeg. It works, but quickly we see that the latency is increased too much and the streaming time is limited to only 3 minutes. So the second thing we explore is the device mirroring features in Android Studio. With this, we can view and interact with the phone screen, but unfortunately, this is closed source. So we came up with developing our own Android app using media protection APIs. But still, the problem is the application cannot run silently in the background because it needs to ask user for runtime permissions. Moreover, now the second question is more difficult: how to inject touch event into Android to control the phone. So to answer this question, the first solution we see is making a system application with inject event permission. But this solution needs to customize Android and root the phone. So this is not exactly what we want. We want a non-intrusive solution. Then we discover that we can run this ADB cell input command to inject touch event into Android. So we think maybe an application running in an Android cell will have privileged permission to do the same things. And at the same time, we discover Screen Copy. It is an open source project that has all the features we need for the Android side. Lightweight, offer good performance and non-intrusive. It runs in Android cell and can capture the screen without asking user for runtime permissions. It can also inject touch event into Android system without needing system permissions or root access. It does not work on Zephyr, but that's not a problem because we will make it. So I will explain how Screen Copy works. There are two applications. When we connect the phone to the computer and run the host app, the host app will set up an ADB tunnel between the Android phone and the computer. Then ADB will transparently handle all the data transport between them. After that, the host app will use ADB to boost the Android app to the phone and launch it in an Android cell, so that it will have all the permission to inject touch to Android. A little bit more detail on that. So on the Android side, screen copy will capture the screen, encode it into H.264 or H.265, and send the stream to the local video socket. The video stream will pass through the ADB tunnel to go to the PC side. Then it will be decoded and displayed on the PC screen. On the PC side, mouse and keyboard events are also captured and sent back to the phone through a separate socket, the control socket, on the same ADB tunnel. So we decided to base our demo on the screen copy project. We removed the host app and replace it by our Zephyr app. Then we leverage the Android app so that it can work with our Zephyr app. We encounter some difficulties. Firstly, ADB is not supported in Zephyr. So we cannot use ADB tunnel, but we can use normal BOSIX socket and can support only TCP/IP, no USB. But we still need ADB running from a PC to push and launch the Android application in the cells. My colleagues will talk more detail about our solutions.
So hello, now we talk about the solution on Zephyr. So on the Zephyr side, we use the platform RT1170 with the display screen, and this platform fully supports the Zephyr. To have the Wi-Fi capability, we use the Murata 2EL module, which is a Wi-Fi module. So this is connected via the SDIO of the M2 slot on the board. And the board will act as an access point, so the phone, Android phone, can connect to it. And on the Zephyr, we have the DHCP server that will assign an IP address for the phone to the communication between the hotspot. And then the phone screen will capture the screen and compress into the JPEG screen and send it to the board. And the board will do the JPEG decoder into the screen. And then the touch event will come from the touch screen and send via the TCP/IP socket to the phone. And for that, we can remotely control the phone. Let's talk about a bit about the architecture. So in our application, we have mainly two sockets, video socket and control socket. But first, we have the DHCP v4 server, which is a built-in Zephyr feature that allows us to assign an IP address to the connected device to the networks. And then the JPEG frame comes from the Wi-Fi interface. We receive via the video socket into the queue, which is a buffer pool. And the JPEG decoder will look into the buffer pool for JPEG frame and then decode it into the raw format YUV420. And then we need to convert it into the format RGB565 using the color converter. And here we use a functionality of the board is a PXP, which allows us to do this conversion. And finally, we display the frame on the display using the display controller ELCDF. And on the other side, we have the input system, which will be pass the input message and convert it into the message, and then send it to the control socket via the TCP/IP. And on top of that, we have the application state machine, which allows us to control these three threads. And here is the following workflow of the control state machine. However, the difficult part here is a buffer pool for receiving the JPEG image because the JPEG image is not fixed, is a variable length. So in order to do that, we use buffer pool. So we need to take a buffer pool that will hold a complete JPEG image. For reminder, we have a JPEG image will be begin with a marker start of frame and end of frame. And here we have a two thread. One thread to decode the JPEG image in the buffer pool, and other thread to receive the JPEG image. And when the frame is full, we can begin the decode, and the receiving thread we move to the other pool to continue to decode. And this approach allows us to parallelization between the two threads. However, this is not ideal because, as I say, JPEG image is not fixed, and we cannot determine the size in advance. As a result, we need to allocate a buffer pool a lot bigger to accommodate the largest possible JPEG image. So this solution is not ideal, and we can think about a solution of using a ring buffer, which could be a better solution. However, in our use case, we prioritize the speed over the memory efficiency. So we choose to go with the buffer pool approach, which is a lot of faster. Now I've talked about how to convert the the Zephyr touch input event into the Android compatible events. So from one touch, with one touch from the input system, it will generate 4 events, as you can see on the screen. So the first is an empty slot. We indicate the pointer ID of the touch. And then we have the absolute X and Y, which is the position of the touch on the touchscreen panels. And then finally, we have the event button touch, which will be 1 if the touch is pressed, and 0 if the touch is released. So we need to convert it into a single screen copy event. So we do that using the parttouch event function. And then this event will be received on the Android side, and this event will be converted into the motion event, and that be later inject into the Android phone. That we can control the Android phones. During our developments, we need to do some modification on the Zephyr system to make our demo works. So the first thing we have done is to modify the PSP driver to allow the support for the color conversion, because it's not supported yet. So secondly, we don't have JPEG decoding support on Zephyr. So we integrate the ffmpeg library with the JPEG decoder into Zephyr. So it's quite easy. We need to modify some CMake files. And finally, we have done the multi-touch support for the ZT911 touch driver. This allows us to have the multi-touch capability for this driver. And now I will show you a little about our system performance. So I will show you the video first. So here is our demo, and you can see that we connect it via the Wi-Fi. Yeah, just a video. They are sound, but I don't know why it did not work. So the second use case, you can use the map navigation on the touch screen. So imagine that we can use on the e-bike or something like that. You can touch and see the screen and navigate on the street. So about the performance, we have the frame rate about 1/11 no, 11 frames per second for a resolution of 720p resolution, and with the latency about 100 to up to 200 milliseconds. However, we have done with another team, we have make with the smaller resolution about 800 and 600 by 600, and the performance can go up to 15 FPS. So our perspective of our demos is our next step is to port the IDB to Zephyr, which allow us to push directly the code from the Zephyr board directly to the Android phone without using the PC actually. And second thing is we would like to use the multi-core processing for the application. For now, only the M7 core is used. And third, we intend to use a more optimized JPEG library instead of using ffmpeg. This will enhance a little of the performance. And finally, we would like to use a hardware video decoder to accelerate the video decoding. So in NXP, we have some board such as RT1170, which supports the JPEG decoder, and this will enhance the performance of the system. And we can think about a new feature that we can use with the phone. So we can send the camera frame from the board to the phone, which allow us to use the hand-free controls and the processing AI tasks we've done on the Android phone, because the Android phone is much powerful on top of computing. So thank you for attending our session. So do you have any question? Hello.
The Android phone is locked when the lock screen is on?
Sorry?
Does it also work the mirroring when you lock the phone?
Yes.
Still continues the mirroring?
But I think you need to unlock on the phone, not on the.
No, actually you can unlock your phone via the touch screen of, you see, on the touch screen of the embedded board.
I don't think we can unlock. Let's try.
Yes, you can try with the pin code. Yeah.
It's down there at the bottom. Pin code, yes, but not with fingerprint.
Yeah. Not with fingerprint, yes. But you can, we can make it in the future. We have the ultrasonic fingerprint under the screen and viewing. Yes.
I'm curious on the performance aspect. I know that I'd seen earlier versions, so I know that the latency got better and better, or improved. But did you do any analysis on the Zephyr side to see where the performance was being consumed throughout the whole stack? I mean,
yes, I have done is using the profiler such as Zephyr RTT, and we can see that weak thread are using the most of the time. And during my journey of profiling, I have seen that actually the ffmpeg JPEG decoder is not optimized for the MCU because it will use the malloc and free frequently. So it's not really optimized for the embedded. So I have just discussed with someone in the booth, and he said that he will someone tried to optimize the libJPEG library for the MCU. Yes.
There was a slide where you had made some modifications to Zephyr drivers.
Yes.
Were they submitted upstream?
Yes.
Yes, GT911 have been upstreamed, and however, the integrated ffmpeg library to Zephyr, it's not. We cannot upstream because to the license, and the PXP driver.
The PXP driver and making another pull request to rework the PXP driver. So I will integrate this back into this pull request.
Oh. So is there a special ffmpeg library for Zephyr, or is the?
No, there is no FFmpeg for Zephyr. We take the code from Linux.
And it worked without any modification?
Yes, no. We did some modification. We remove some background we not need, and we do some CMake file just to combine.
Mhm.
So where is that in the NXP Git repo?
No, they took it from Linux.
No, but the modified.
The changes, yeah, because
Yeah.
those would be useful for anyone wanting to use this on Zephyr, right? Maybe you can push them back on Linux or at least on our repo.
No, actually, it's not work because it's a simplification of the library.
FFmpeg is under GPL license, and we cannot upstream it back into Zephyr mainline. But I think we can put it in our GitHub
Yeah.
repo.
Have you taken a look at the STD nothing? We have a header-only implementation of the
That's these guys.
Sorry?
There's a, I don't know what license it's at, but it's really free. The STD nothings, it has a lot of single header include files. I think one of them is a JPEG as well. It uses malloc and free also, but it's quite optimal for the.
So you say that in FFmpeg there is multiple license or?
No, it's a completely different repository, but it's a very popular one for people tinkering with embedded devices. I can share it.
What is it?
STB nothing. If you look that up on Google.
Oh, thank you.
Did you try this demo with the Ethernet over 1170?
Yes.
Without Wi-Fi?
The first demo is running on Ethernet, and then we change to Wi-Fi.
So is the performance good?
The performance is nearly the same, I think.
No, the performance on Ethernet is much better with lower latency, but on the Wi-Fi it's okay, I think.
Because for our demo, I think the difficulty is not about the bandwidth, because with Wi-Fi or Ethernet, the bandwidth is enough for our demo. But the difficulty is in the CPU usage, because the decoding use so much CPU. So to improve the demo, we need to do something in the CPU usage.
Yeah, so you're using the M7 core.
Yeah.
Only.
We plan to use two cores, one core, the M7 core for decoding and the M4 core for all other things.
Have you thought about using an RT with a DSP so that you do the decoding on the DSP?
We have
RT 600?
Yeah. However, I think we need to do our proper JPEG library for the DSP.
Yeah.
It's a huge of work.
Maybe we could find one already done for the Hi-Fi 4
Oh, yes.
from Cadence.
But on the RT700, we have already JPEG decoder for the information. Yes?
Maybe you mentioned that and then just missed it, but you also looked into this Android Auto protocol, whatever they use there. I don't know the details. That would also be kind of possible to provide it with this Zephyr system.
In fact, in our first slide,
Yeah.
we already explored some solutions with Android, but all of it does not meet our requirement.
Okay.
For example, we can use screen recorder in Android to do screen mirroring, but it works just for 3 minutes.
Okay.
And I think because the screen recorder in Android is made for the debugging purpose only, so that not fit for streaming.
Okay. So it was more like a
Yeah, we
case thing.
yeah. we testing nearly all solutions, and we came up with screen copy. I think this, for now it's the only solution that non-intrusive. We don't need to root the phone or customize Android.
Yeah, but I think what he's also referring to is like the connected car consortium. They define protocols for, it's not screen mirroring, but it's like the application extension to a console or something like that. So it's like CarPlay, or Apple CarPlay, Android CarPlay, whatever they call it
Yeah.
in the Android space.
Yeah. That's one feature that we need to think about because for now we mirror the entire screen, so that's not very good. We just need to mirror the application. For example, we mirror only the Google Maps.
So, the intended use is not to mirror the screen directly, as I understand it. And you would not be having any problem with like activities that are flagged for secure. So in screen recorder, you cannot record screens that are in like a screen secure activity or whatever. You don't have any trouble with that?
The security issue.
Yeah, like because of you have flagged an activity as a secure activity, then the screen recorder blacks out that screen. You cannot see it on a mirrored screen.
IDB ấy, mình không có vì mình dùng IDB.
If you open a bank app, for example, the bank.
Yeah, I think for some security, I didn't test the bank app, but I test the a secret folder in photo, and when I open it does not mirror on the board. So I think Android already has some security fence to prevent us to do that.
Right. Part of the exercise here was also just to see how far we can push things with Zephyr on the MCU platform.
Yeah.
And this was a pretty cool way of leveraging it.
Absolutely.
Very cool.
Any questions? Thank you.
Thank you.